Okay, so let's take a look at creating our first simple program in Eclipse. Since Eclipse is project-based, all the programs that we construct have to be associated with a project. So the first thing we need to do is actually create a C++ project. And we could do that by going to File, New, and then coming over here to C++ Project, left-clicking on it, and now we get a little dialog box here. And it wants us to specify the project name. So the project name here is just going to be maybe first project, since this is our first project. Under project type, select empty project, and under tool chains, make sure min.gw.gcc is selected. Okay. Once you've done that, you can click on finish. And now over here under Project Explorer, we should see first project. If you don't see Project Explorer here, you should be able to go under Window, Show View, and then select Project Explorer, but it should be showing up by default. So over here we do have our project, and basically this first project is a folder on our system stored in our workspace, wherever you designated your workspace to be. So what we can do now is actually add in a C++ source file to this project. So let's go ahead and right-click on First Project, go to New, and then we can select Source File. Okay, so this is where we're actually going to name our source file. In our case, since we named the project First Project, let's name the source file First Program. And we need to provide an extension here of .cpp. So CPP is just the default naming convention for C++ source files. For template, if you have it selected to default C++ source template, change that to be none, and then click Finish. Okay, so now we're ready to start typing in our first program. So you should see a tab here that has the name of your source file. If you named it something else other than firstprogram.cpp, then you'll see that name appear there. So right below that, let's just left-click and start typing our first line of code. So the first line of code is going to be pound, include, space, open angle bracket, and Eclipse should automatically insert a close angle bracket there for you. So in between the open angle bracket and the close angle bracket, let's type IOStream. So what does this line of code actually mean? Well, the pound include is what we call an include directive. And it's saying to make some set of facilities provided in some other code available to us in this program. In this case, we're saying include IOStream. And IOStream is part of the C++ standard library. And what we want to use from the IOStream is the facility that allows us to get input from the keyboard and to output text to the monitor. Okay, so go ahead and hit enter, and we'll type in our next line of code. So the next line of code is going to look like this. Using space, namespace, space, std, semicolon. I don't want to say too much about this particular line of code at this time, other than it's going to save us a few keystrokes, but we'll revisit the concept of namespaces later when we discuss such concepts as functions, classes, and scope. Okay, so we're ready to write our next few lines of code now. Go ahead and hit the enter key twice, and we're going to write several lines of code and then come back and explain these lines of code. So type in int space main, open parentheses, and Eclipse should automatically insert a close parentheses for you. Come on the other side of that close parentheses, hit enter again, and now you want to enter in a brace. Okay, so on your keyboard that will probably be the shift key and the open square bracket. So that will get you to the open brace. Hit enter again. And you'll notice that Eclipse automatically inserts a close brace for you. And it's also moved our insertion space over some. And this is perfectly fine. In general, when we have an open brace and a closed brace, we want to move all the text within that open brace and closed brace over by some level of indentation. I think here we're doing 4 spaces. So now we're going to type in cout space, and then we're going to use the open angle bracket twice, space, and then we're going to use double quotes. So you'll notice that Eclipse automatically inserts the closed double quotes for us. And then we'll type C++ is fun, exclamation point, and then we want to have a /n, And then we're going to come on the other side of the close parentheses, the close quotation mark, double quotes, and hit the semicolon, and then hit enter, and then we want to type in return space 0 semicolon. Okay, so let's talk about this code that we've written. This code here is what we call the main function. So it starts here and it ends here. The very first line that we have here is what's called the main function's header. And then the rest of it is what's called the body of the main function. In general, when we talk about a function, it's just some sort of name set of instructions related to performing some particular task. And later on, we'll look at writing additional functions besides the main function. So every single C++ program requires a main function, because this is where program execution actually starts. Whenever we run our particular program, it's going to start executing in the main function. So let's look at the actual code within the body. So the body starts here at the open brace and stops here at the close brace. And all the code that's within that is part of the body of that function. So here our first line of code has the cout. And cout stands for character output stream, and it's providing us with the ability to display characters to the screen. So whenever we run this particular program, hopefully we'll get something displayed on the screen. The next part here, we have these two open angle brackets. And this is what's called the output or the insertion operator. And it takes whatever we have here on the right-hand side and redirects it to what we have on the left-hand side. So in this particular case, it's sending the text C++ is fun to cout, which in turn displays the text on the screen. Now toward the end of this, you'll see this /n, and that's a little bit peculiar or unusual. And really what's going on here is we're denoting a new line character. So we have a special character here, /n, and that denotes a new line character. So whenever we print this out on the screen, it's going to have C++ is fun, and then a new line character. So it turns out that all C++ statements should be terminated by a semicolon. So this is in fact a statement that we have, and at the end you'll see that we do in fact have a semicolon. All right, so let's look at the next and last line of code here in the main function. It says return 0 semicolon. So it looks like a statement once again. In this case, this function main is returning the value of 0. And it turns out that with all functions, we can have a return type specified. Here, if we look back at the main function header, the very first thing we have here is specifying the return type. So the return type specified here was an integer type. So this means that this function, when all is said and done, has to return a value that's of integer type. And that's exactly what we're doing here. We're returning the value of 0. And this 0 here just simply indicates that our program terminated or ran successfully. You may be wondering, where is this being returned to? Well, it's returning to whoever called main, whoever invoked main. Later on, we'll be invoking other or calling other functions from main or from other functions. So whenever we talk about something being returned, it's being returned to whoever invoked or called that particular function. Okay, so now that we've discussed the code in our first program, we're about ready to run it, but there's a couple of more things that we need to do. One thing that we need to do is actually save this particular program file. You'll notice here that next to the first program.cpp name that we have a little asterisk or star here. This is indicating that we have not actually saved this particular file back since we last modified it. So what we'll do now is actually save it. So you can click on or hold down the control key and hit S. That's one way to do a save. Or you can come over here on the toolbar and click on the little diskette. And that's what I'm going to do, is just click on the little diskette icon, and now you'll see that the little asterisk or star has been removed, indicating that this is up to date. We have the latest and greatest. Okay, so the next thing that we're going to do is actually build this particular project. And the way that we're going to do that is to use this little button here, which is our build tool button, or our build button. And the build process really takes place in two stages. The first stage is going to be a compilation process in which it's going to compile all of the C++ code. What does that mean? That means it's going to transform this particular code here into machine code. That means code that this particular computer system can understand and run. The next thing that is going to take place in the build process is a linking phase. And what's going to transpire there is it's going to link the machine code that was generated from our first program along with other machine code from some of the library files that we made use of from IOStream. And at that point in time, it's going to generate an executable file. And that executable file is the whole kit and caboodle that will actually run this particular program. Go ahead and click on the build button here, and we'll build our project. You'll notice here on the console that we have some things going on as well. You can see what compiler was actually invoked. There were some options associated with this particular compiler. And you can also see that we generated a first project.exe. So this is an actual executable file. And if we come over here to Project Explorer, you can also see that we have an executable file. So go ahead and left click on the little button next to first project. It may be a triangle, it may be a little plus symbol. In my case, it's a little triangle, and that should expand out the listing. And then it's also the same case here with the binary, so we want to expand out the listing there. So here you can see that we have first project.exe, and you can also see this x86. This is indicating the architecture that this particular executable will actually run on. So in this case, it's saying that it'll run on x86. So those are your Intel processors and your AMD processors. All right, so let's try to actually run this program and see what transpires. So I'm going to go up here again to the toolbar and click on the Run button. So again, it's the little green button with the white play button or the white triangle button. So go ahead and left click on it, and we'll see what happens. Okay, down here, if we look at our console, you'll see that we did, in fact, get C++ is fun. So it looked like our program did exactly what we expected it to do, to print out to the console or to the screen, to the monitor, C++ is fun. All right, so in this video, we're going to be looking at the concept of a variable, also looking at assignment statements, and then finally some of the various data types that are supported by C++. And then in the next video, we'll look at using some of these concepts and constructing a new program. Okay, so oftentimes when we write a program, we're interested in being able to store some particular data value and then make use of that particular data later on. And the way that we can go about doing that is introducing this concept of a variable. And a variable is just simply a named location in memory. And the reason why we want to have a named location in memory as opposed to an unnamed location is that we want to be able to quickly and easily retrieve some particular value that we've stored at a memory location. If we did not have a name for that location, then we would be relying upon the actual address, and we'd have to keep track of some sequence of numbers, sequence of digits of the address value in order to reference that particular value that we've stored. But we don't have to do that. So again, a variable is just simply a named location in memory. So we may write a program in which we ask a user for their age. And so the way that we can do that in C++ is that we have to specify both the type of variable that we're going to have and also the name associated with the variable. So in our age case, we could have the type being int to stand for integer. So this is one of the data types, built-in data types that C++ supports. And then the name would be age. We'll put a semicolon there. So this is just a simple declaration statement here where we've specified a type and a name for a variable. And so what happens is we get a space or chunk of memory allocated to us, and associated with that chunk is the actual name age, and then the type was going to be int. So we've got type here, and we have the name here. This is just a logical view of what's going on. And we can also assign a value to this particular memory location. It's actually going to have some value in here whenever we first do this declaration. But in reality, you want to assign a value straight away after you make a declaration. So it's just good programming practice to assign a value straight away. So we'll say age, and we'll put 18. And so what effectively happens there is we end up with the value of 18 stored at that particular memory location. So anytime that we want to be able to get access and make use of this value of 18, we can do it through its name age. And there's other data types other than just the integer data type. There's other numeric types, so we'll learn about maybe the float and the double, the short, the byte later on. But there's also types that support characters and then sequence of characters. So maybe we're interested in getting someone's first name or their last name. Then we could introduce a variable of type string. So a string supports a sequence of characters. So let's go down here and actually declare another variable, and we'll say that it's of type string, and we'll call the name of this variable just simply first name. So we've declared a new variable, so we get a chunk of memory allocated for us, and associated with that is we have first name. Okay, so this is just simply the name of the variable. Some people will refer to this as the identifier, but the identifier is basically a fancy word for name. And the type here is going to be string. And the way we have this now is that we've simply declared the variable, but we haven't initialized it to anything. So there'll be some sort of garbage here whenever we do this declaration. You can actually do a declaration and initialization all in one line. So instead of doing what we just did, I'm going to mark this out, is actually we could do string, first name, and then do the assignment operation as well. So that way we're assigning a value straight away and we don't have to worry about this garbage. And this is good programming practice. So whenever we declare a variable, to assign it to a value, or assign a value to a variable. So we'll say the first name here is just simply Bob. And you'll notice that whenever I wrote Bob, I put it inside of double quotes. This is required in order to represent that Bob is in fact a string. So any string that you're going to be writing out, what we call a string literal, that we write out in C++, we have to put it inside double quotes. So over here I'll represent Bob as being stored at this memory location that has first name. So that's the basic idea behind variables and assignment statements. A variable is just simply a named location in memory, and we can assign values to that particular named location in memory via the assignment operator. So this is in fact an assignment statement in which we are declaring a variable and assigning a value using the assignment operator. Here we've declared a variable, selected a value that we want to store there, and then using an assignment operator, we're storing at that memory location. And that's basically it. So variables and assignment statements in a nutshell. All right, so let's talk about some of the other types that are supported by C++. And so when I say data types, or use this term data types, we're saying that in memory, how much space is going to be allocated, and then what types of data can we actually store there. Can we store numeric values? Can we store a sequence of characters? Can we store a single character? All this comes down to the data type or the type of data. All right, so we've mentioned briefly about the int, and we know that int data types can store integer values. So these are numbers that would not have a fractional part. And the int data type also has a specific range of values that it can support. But I'm not going to get into the actual range just yet. We may look at that on another day. But in terms of the amount of space that's actually allocated, on a lot of systems it will be 4 bytes. Now it depends on the underlying architecture processor and also what compiler in terms of how much space is actually allocated. We also looked at the string data type. So we saw maybe an example here where we have the string Bob, and we were able to store it into some variable out there in memory with this name called name. Maybe first name, I think was our example previously. And then we could have a string representation of a number. So we have 21 here. So you see that 21 has double quotes around it, but we're storing it into a string variable, in this case called movie. So it may be the title of some particular movie. So always with our string values, the string values will be surrounded by double quotes. Just to contrast that, we see here in the next example where we have another int data type being declared. This time we're using the variable name num, and we're taking 21 and storing it into that particular memory location designated by the name num. So this guy and this guy are two very different animals out there in memory in terms of the amount of space that's actually going to be allocated, and also in terms of the actual operations that we can perform. So with this particular variable here called num, we can actually perform numeric calculations. So we could actually multiply num by some other value or divide it by some value. If we try to do the same sort of operations, numeric operations with movie here, it wouldn't work because this is a string representation. So to us, these may look very similar, but in terms of the way this is represented behind the scenes and the type of operations we can do, they're very different animals. I don't have a mention over here for the actual space that's going to be allocated for strings. This varies according to not only the processor and compiler, but also the size of the string. So you can imagine that a very long string would require more memory than a very short string. All right, so another numeric data type is double. So we see an example here where we've declared a variable of type double and assigned the value 165.8 to that particular memory location designated by weight. So here with double values, we can actually support numbers that have a fractional part or a representation of real numbers. And that's not the case with ints. With ints, you cannot support fractional parts, as the name int means. We're talking about the counting numbers, both in the positive and negative direction, and 0 as well. All right, so on a lot of systems, a double will be 8 bytes. That varies again. Next, we'll look at character representation. So if we're interested in representing just a single character in our program, then we can use a character variable. So we have the type being char, the name here just being letter, and here we actually have a character literal. So character literals are surrounded by single quotes, whereas string literals are surrounded by double quotes. Okay, so we have single quotes there. So we could not go in here and assign any representation that has double quotes to a character variable. So if we were to come here and type out double quote A, double quote, and try to assign it here, the compiler would complain about that because that is not the types of values that characters support. And it usually has a single byte allocated for a character. And then finally we have the Boolean data type, and the Boolean data type is used for storing true-false values. So we may be writing a game program in which we have a variable called game1, and we can set that particular value to true maybe under certain circumstances. So in this case, only 2 different values could be stored in game1, true or false, and typically you have a byte allocated in memory for the Boolean data type. So again, this is just a brief listing of some of the other data types that C++ uses, and we'll be using some of these in our future programs. Okay, I think we're ready to write our second program. And in this program, we're going to just simply prompt the user to enter in their name, and then prompt them to enter in their age, and then display their name and their age. So we'll make use of some of the concepts that we've recently covered dealing with variables, and we'll also look at the concept of getting input from the user. So we haven't done that before. We've just done output to the screen. Okay, so let's go ahead and create our project. So we'll go here to File, New, C++ Project, and we're going to call this C++ Project Program 2. For project type, leave it as empty project. Tool chain, make sure MinGW GCC is selected if you have more than one tool chain, and click on Finish. And now that we have our project here under Project Explorer, go ahead and right click, select New, and then we'll select Source File. And we'll name the source file the same thing as the program, except we need to have the CPP extension. Okay, so that's just convention for our C++ source files. And click on Finish. So here we go. We're in our editor now. We can start typing. The first line is going to be the same first line we saw in our other program. We're going to have a pound include, open angle bracket, IO stream. So this IO stream is bringing in the facilities to be able to do input, getting input from the keyboard, and also doing output to the screen. The other thing that we're going to have here is support for the string data type. So we actually need to bring in another library for that. So we need to do pound include open angle bracket, and it's just string here. Okay, come down a couple of lines, and then we'll have the using namespace space standard. Again, I'm not going to go into the details of this just yet, other than to say that it's going to save us a few keystrokes. So now we can type in our main function. So int main open paren close paren, come down a line, open brace, enter, and it should automatically insert our close brace. So everything is going well so far. So this is the basic structure of our program. It doesn't look too different than what we had before at this time, other than we had this pound include for the string library from the C++ standard library. Okay, so now we can, I guess one thing that we could do at this particular time is just do a return 0 here inside of our main function. So our main function is supposed to return an int value, and if things are successful, we should return a value of 0. So in this program, we're getting both a name and an age from the user, so we need to declare variables that are able to support those types. So to support the name, we'll have a type string, and the name of the variable will be name, and then we'll initialize it to the empty string. So the empty string is just double quote, no space, double quote. And for some reason or another, Eclipse is complaining about string here. So let's go ahead and save and see if we can get it from complaining. I don't know, do a space in there. Okay, there it goes. So for whatever reason, it was a little bit delayed in recognizing that we did in fact have the string library. But things are okay now. It's not complaining. It fully recognizes that. So we're good to go. The other thing that we need to declare is a variable for age. So we'll do int age, and we'll also initialize it, and we'll initialize it to 0. So it's a good idea to always initialize your variables as soon as you declare them, even if you overwrite them, shortly after this. So what do we need to do now? At this point, we need to prompt the user to input their name. So if you remember the way we got output to the screen, we use cout. So cout, and then we use the insertion operator, and then we could type some text. So maybe enter your name, colon, space, and we'll do /n here to put a new line character there. All right. And then we'll do, actually we'll do something new here. So let's do cin. So instead of cout for doing character output, we can do cin for character input. So cin space, and this time, instead of doing the insertion operation, we're going to do what's called extraction. We could also call this the input operator, where we're getting input from the keyboard. So it goes in the other direction, so close angle bracket, space, and now we need to say what are we actually putting the keyboard input, whatever they type in, maybe their name is Bob, and where are we going to store that particular value? Well, we want to store it into name. So we put name here. Come down a couple of lines. We'll do another series of 2 lines just like this, except this time we're going to use enter your age, colon. And maybe I won't put the new line character in there so you can see the difference between having the new line character and not having the new line character. We really didn't get a nice showcase of the difference in our last program, but we'll see it here. And put semicolon there. And then we'll do cin and use our extraction operator, extracting something from the keyboard and placing it into, in this case, the variable age. So now whatever they've typed in after enter your name will be stored in name, and then whatever they've typed in after enter your age will be stored in age. All right, and then finally we'll output to them basically the same information that they inputted to us. So we'll say cout and then use the insertion operator and just say your name is colon, and then insertion operator again, name, and then maybe after that we put a period. And let's make use of the new line character again. See how this works. So new line character, and then we'll say your age is, space, then come on the other side of that, and then we'll say age, and then we'll end that line with a period as well. So let's go ahead and put a period in there. Whoops, not a comma, but a period. And then put a semicolon at the end. So each time that we're interested in specifying a string literal, we need to make sure that that string literal is inside of double quotes. Whereas if we have some variable, we just type the variable name as it is. Okay. Kind of showing, I guess, logical grouping of what we're doing here. This is logically declaring our variables, prompting the user for their name, then getting their name, prompting the user for the age, then getting the age, and then displaying both the user's names and their age. Okay. All right, so let's go ahead and save this. Okay, so now we're ready to compile our program. So go ahead and click on the build button here. And again, the build button involves both compiling and linking. So we're compiling this code here and generating an object file that will be linked with other object files from IOStream and string library. And then we'll generate an executable file that runs on this particular architecture. So all that's going on whenever we click this build button here. And now we'll actually run our program by clicking on the Run button. And down here on the console, we'll actually have to input some things from the keyboard. So it says enter your name. And if we left-click somewhere within this console, you'll notice that it puts the insertion point here below enter your name. And that's because we put this new line character. If we didn't put the new line character in there, then we'd be inputting the name on the same line as enter your name. So we'll say that the name is Bob. And then now it's just waiting. Maybe our name's Bobby, so we could type in BY, or maybe we put a first name and a last name in there. It's not going to do anything more until we hit the enter button. So it's basically waiting for us to say that we're done typing our name. So hit enter, and now we're going to enter our age. And maybe the age of Bobby is 22. So we'll put 22 in there and hit enter. And now it says your name is Bob and your age is 22. So all that came from this single line here. And even though we typed it out on a single line, it showed up on two different lines. Why did it show up on two different lines? Well, we inserted this new line character. So after it finished all this stuff here, all the way up to that period, it then provided that new line character starting here and put all this stuff on that next line. Okay. And notice how it substituted in the actual name Bob, where we had name here, put Bob, and where we had age, it substituted in 22. So that's what's going to happen whenever you output some statement and you're using variables. It's actually going to replace that particular variable name with the value that's stored at that variable location. So that's basically it. This is our second program. We looked at declaring a couple of variables of different types, one of type string, the other of type int. We also looked at using cin to get input from the keyboard, and then we reviewed using cout. So in our next program, we'll probably be doing some maybe basic arithmetic operations.